And we're live. Good morning, everyone. Brian Armentrout with the Food Safety Foundation on a kind of a windy, not quite as hot day here in Colorado. Jose, my friend, how are you doing today?
Oh, I'm doing great, but you know what? I'm laughing because whenever we start and talk about weather, it's just amazing because you never know which is going to be the answer. Is it cold? Is it hot? I mean,
Colorado's all over the place. We're kind of in the middle now of a heat wave. It was 95 degrees here yesterday. But again, no humidity, right? So it cools down at night, so it's fine. But that's been going on down here for a little bit. So we'll see how that goes. How's the weather in Florida?
well, you know what? Has not been that bad. I'm going to say we're in June already, very close to what is that? Solstice. So the longest day of the year is coming up in June 21st, June 22nd, something like that.
Yeah.
And the more exposure do you have to the sun, well, things are going to get hotter, but has not been that bad.
No, oh, that's good. That's good. Yep.
Humidity still is 80 something right now outside.
Well, I mean, yeah. So the summer solstice, that's a good way to think of whether you're a pessimist or an optimist, right? Because if you're a pessimist, the days start getting shorter. If you're an optimist, it's like, hey, yay, the longest day of the year. Right? So the trek
you're right.
begins. So of course, on Fridays, Jose and I, so of course, Jose is with the Food Safety Consulting team. Jose, his email is down here, sabalfsc.com. Mine is on here as well with the Food Safety Foundation. And we get together every Friday at this time, so 10 a.m. Eastern, and we talk about food safety. And one of these things that we do with this is a discussion on a particular topic. Today, we're talking about calibration. And this is interactive. So we encourage questions and conversations between the people attending because we're live on LinkedIn, Facebook, YouTube, and Twitter all at the same time. So please log in and say hello to us and let us know where you're contacting us from. As I said, I'm in Loveland, Colorado. And I'm always amazed on this live stream, Jose. I mean, we have people from all over the world who participate. India, Turkey, Nigeria, you name it. And of course, I'm in Colorado, beautiful Colorado.
And I just, kicked in saying, hey, I'm in Miramar, Florida.
There we go. So please, everybody, check in and say hi. One of the things that we do on this, and it's always funny because it's in the back of my mind and it always seems to pop up at a weird time, is join us for a drink up with your beverage this morning.
Oh, and yes.
So, of course, mine is my lovely coffee, and Jose has his beautiful tea.
This is going to be good.
Very good.
Yes, I need it.
Worthwhile. Stephanie, good to see you, our friend in Germany. Alba, good to see you again in the Bay Area. Very nice out there.
Good morning.
Very nice in the California side of things. So today's topic, it's an interesting one with calibration because it seems to me, Jose, that this is something that kind of a lot of times is an afterthought and people aren't really, they're focusing on the big things. Oh, my food safety plan and training and allergens and all these type of things, and calibration kind of gets missed.
I agree with you, Brian. And you know what is the scary thing about this is that we may have a wonderfully developed hazard analysis. We identify precisely what is the hazard of concern, and we're going to say we're going to control it with the pH or water activity, and then we go to our tables, and we find that the FDA says that in order for you to control whatever, salmonella, you need to go below 0.94 in water activity. Well, how do you measure that?
Yeah. Well, and the thing is too, right, you're only as good as your data. And if you don't trust your data, or worse, FDA comes in and doesn't trust your data, right? It's all for nothing. You have to be able to defend your data. And calibration is how you start with that.
And I mean, we were talking about these, Brian, just a few minutes before going live. But I mean, we still need to remember that once we go through our hazard analysis and we identify a hazard that will cause illness or injury, which is in HACCP terminology is a significant hazard. And under the preventive controls is a hazard that requires a preventive control. So the preventive control, which is most likely principle number 4, monitoring, is going to rely on defining some criteria that is the one that will define when the product is safe, when the process is valid, and or when we have a deviation and when we have non-conforming product.
Mm.
And no matter how good is our hazard analysis, no matter how detailed is our control measure and principle number 4, no matter how good we train the person responsible for monitoring, no matter how well we define that criteria that we're going to use, if we use an instrument that is not accurate enough and that we do not know if it's properly calibrated or not against a standard that that is it's a reference, is a reliable reference, well, we just totally miss the boat just because of the equipment that we're using.
Yes, and there has been some pretty big recalls recently here in canned foods, and the information from FDA, what it was 1.6 million cans were recalled because the temperature monitoring was incorrect. So FDA, right? We don't know exactly what happened, but we can kind of guess, right?
Yes.
So FDA went into the facility, started looking at the documentation because, right, canning and getting your temperature and your time super, super critical, right? You don't want botulism growing in your product. That's super dangerous. And FDA went in to look at the records and said, here, it shows that you had this temperature for this time and everything. Okay, looking good. I want to see your calibration records for your thermometers for your indicating process.
Yep.
Oh, yeah, here it is. This is not right. You are 3 degrees or whatever cooler than you think you are.
Yep.
All these cans. Right. Now, as I had put a post on LinkedIn a while ago, ask that company how important calibration is.
Oh, yes, of course. Well, 1.6 million cans. I can tell you the cost of that calibration.
Exactly. Exactly. Because that got overlooked. Good morning, Bella from Southern California, and Daniel, facts. Oh, yes, absolutely. Facts, very important. So one of the things,
Bryan.
Yes.
No, go ahead, please.
No. I was going to segue into the part that in the beginning is super important that I love that you do is the regs. And what is the base of what we're looking at?
Oh, that's a good one. Okay, because I do have them here. Bryan, the GMPs. Okay. GMPs are now in 117, 21 CFR 117, the good manufacturing practices, hazard analysis, and risk-based preventive control for human food. Yeah. So in that regulation, you go to the GMPs, which is Super B. And in Super B, you have in 117.40, which is equipment. 117.40 E as in echo says that each freezer and cold storage compartment used to store or hold food capable of supporting growth of microorganisms must be fitted with an indicated thermometer, temperature measuring device, or temperature recording device so installed as to show the temperature accurately within the compartment. Accurately is the word that there makes the huge difference. It's not just placing any kind of thermometer. It's placing an accurate thermometer.
Right.
And then the next one, F as in Frank, says instruments and controls used for measuring, regulating, or recording temperatures, pH, acidity, water activity, or any other condition that is going to control or prevent, undesirable microorganisms in food must be accurate, must be precise, properly maintained, and adequate in number for their designated use.
Wow.
Look at how that is written. And we think that just by following the requirements of the SQF, we're fine. No, this statement has only 3 lines. This paragraph has 3 lines. And in these 3 lines, adequate number of instruments and making sure that we have a designated use for each and every single instrument.
Mm-hmm.
That is extremely, precise requirement.
Yeah. Well, and then the things that aren't written there that implies that if you have those, how do you keep track of that, right? So then you need a system for tracking and measurement and what is for what location and how often does it need to be calibrated and all those type of things.
Yep.
What's interesting with that too, Jose, so something came to mind as well as you were going over those rules, right? If you're monitoring temperature in a cooler or a freezer or things like that, where in that freezer or cooler do you monitor temperature? Because it's not the same. It's going to be colder by the fans in the back versus the door in the front. So what's the temperature? Right? You need to figure out the worst case.
So to your point, Bryan, I have been acting in many cases because of the engineering background. I have been doing, some process authority work. I've been validating authorization processes. I have been also validating the cooling chambers, the coolers and the freezers.
Yeah. Mm-hmm.
You need to understand what is the behavior, which are the cold spots, and in the cooler is going to be the hot spots.
Yeah.
And once you understand that, how that works, is where you're going to identify the place where you are going to install the sensors of that unit.
Yep, absolutely. And validate, super important word in what you just said there. And I think it's kind of a good segue to kind of talk a little bit about, because people get confused on this, Jose, is validation versus verification, right? Very different. You're talking validate, right? Not verify. Yep. So the easiest example for me is validation is let's talk like a metal detector, right? So you need to validate it for its use, right? So you need to, let's say you're a QA manager, you need to install a metal detector. Are you just going to install any metal detector and say they're all good, all the same? No, they are not all the same. The accuracy and the ability to detect metal particles in product is dependent upon the aperture size that the product is going through the metal detector. The bigger the aperture, the bigger the particle its limit is, right? It can't detect smaller and smaller particles, right? So if you're running a 50-pound bag of non-fat dry milk through a very large aperture, it's not going to be very sensitive, right? It's not going to be able to pick up things. So you need to figure out the right size. You also need to figure out what's your line speed, how many different products are going through, all this type of information that you need to get to the manufacturer of the metal detector. And then the validation part begins. That company comes in and sets it up, right? They run your product through, they change the field strength values. They figure out, to your point, it's less sensitive at the sides versus the center, right? So they'll run product by the side on the calibration of the conveyor belt, and they'll figure all these parameters out, and then they'll set it all up, and then they give you the test wands and say, okay, now you need to verify when you're running that this setup is doing what it's supposed to do, right? Yep. Validate versus verification, very different things. So to your point, you need to validate that cooler is cooling like you think it does. And then you need to verify and maintain different subjects, and calibration is critical to that.
Yep, 100%. And by the way, Bryan, I'm just going to remind everybody here, hearing us today, now that you touch the metal detector, okay, keep in mind that, and I'm going to read the regulation 117.80 C as in Charlie 8. Adequate measures must be taken to protect against the inclusion of metal or any other extraneous material. Why? Because metal and plastic and wood and rubber and gaskets and so on, and ceramics and glass are not food, and for that reason can never be with the food. So a metal detector is just a verification activity in a system, and your controls are actually your maintenance program, the frequent inspection of the equipment to make sure that it remains in good shape, and blah, blah, blah. Be careful.
Absolutely. A little trivia for you here. So I did an analysis of 2020 recalls. It was almost split 50-50 between metal and other things that were causes for recall for foreign material, right? So don't forget, I mean, you're making a really good point here, Jose. Don't forget wood and plastic and all these other things that can get into the product. It's just not metal, right? Half of the recalls were other things other than metal.
Okay, so again, why using a metal detector if your potential adulterant is wood or glass or plastic or a gasket? Why you're using a metal detector? And by the way, even if you're using a metal detector, if you're purchasing equipment that was built with top technology, they will be using a stainless steel 316, which is a type of stainless steel that is designed for food applications. Well, guess what? If that is the metal, the type of metal that is designed for food contact and the building of the equipment and so on, stainless steel is something that is called austenistic, meaning it's not magnetic. The metal detector is not going to detect that. You will need an X-ray to identify the piece. And again, assuming that the density of the metal is different from the density of your product.
Right? Yep, because a lot of people say, oh, X-ray, that'll fix everything. No.
Yeah.
I've worked with lots of companies that have had real hard times setting up X-rays and getting it to work properly because of that density difference. You're absolutely right. So for calibration, one of the things, and I've gone back and forth with auditors on this from different companies, and you have to look at your calibration system in buckets because you have all kinds of things, Jose, in your plant that need calibrated. You have scales and thermometers and metal detectors and you name it, right? All kinds of things that are calibrated. They're not all the same for importance, right? You need to think in terms of three main buckets. Food safety, right? We're talking about that X-ray, metal detector, things like that, right? Has to be unimpeachable. You have to have the best. We'll talk more about this, right, of what that is. Food quality is also important, but we're not talking food safety, right? So we're talking, let's say, pH meters or other things that are important for making sure your product meets specification, but it's not a food safety issue for this discussion. And then there's all the things that operations uses that need to be calibrated. So load cells on silos and flow meters and all kinds of things. Those need to be calibrated too for the efficient operation of the facility, right? But they're different, right? They need to be calibrated, yes, but your reaction when you have an out of spec situation or a failure with that calibratable equipment is going to be different.
Yep. And not only different, Brian, again, like in any other system, when we design systems, one of the most important things that people on a regular basis misses is identifying how you're going to break production. When you are going to have a clean break at any, whatever is that break, but when you are designing breaks, because those breaks are the ones that will help the company to make sure that if there is any problem, which calibration and accuracy checks, making sure that your instrument is in good shape, also will be the reason for a recall. You just mentioned the recall of all of those million and something cans. Why? Because the instruments were not calibrated. That's it. So how many breaks do you have in your system in order to determine the quantity of the product that will be recalled?
Right. And the company needs to understand that because, if you're running a thermal process canning facility, and let's say that you've got a continuous system, that's a lot of energy, a lot of heat, a lot of money getting those things up and running, right? So they run for long periods of time. So to your point, Jose, your bookends is huge. You have very large lots. The company needs to understand that that is risk, right? Yeah. If you can break it up into smaller segments, you reduce your risk because if you do have an issue, you're going to be recalling a smaller amount, hopefully, right? If you have good bookends where you can then show FDA that, yep, this is the product that's involved with this, and this is all that we need to do, right? Which gets back to your investigation piece, right? Which is why we have metal detector verification checks let's say hourly, right? Because now you know that if you have an issue and you go to check your metal detector, you go back to the last good check. And okay, everything from the last good check is potentially containing metal. We need to go back and put that on hold and do our investigation, right? And get the metal detector fixed, run it through. There's even companies, a lot of people don't know this, there's even companies that specialize in this, that if you have an issue, you can send your product to them and they'll run it through their equipment to make sure it's okay. But you need to set that up in advance and know that that equipment is going to be good for your product, right? Just like the purchase of your stuff, you need to make sure just not any piece of equipment is going to work.
Bryan, two examples, just to, show up a little bit exactly what you're talking about. So I was auditing many years ago. I was auditing this facility, and they created a new product. And this new product is a liquid product, so it needs to be heated in order to take care of salmonella. Salmonella is the hazard of concern. The heating of the process is the control, and it's a batch. So good deal. So there is a clean cut between one and the other. So that process was set up between 1 year and the next year. So when I arrived the second year or the third one, maybe, I don't know, recall, I said, do you have a new product? And they say, yes, we do. Okay, can I see the documentation that you use for this new product? And they show me everything. And I went there and I saw they have a panel, they have a PLC, it's a computer, and the computer is connected with thermocouple wire to some RTDs located at the equipment, sensing and then sending the signal back. And then the equipment is controlling. Well, I saw the report from the process authority saying that they need to go above 165 to effectively kill salmonella for whatever amount of time. Okay. So I then went to the guy that was actually doing the monitor. And I say, hey, how are you? I'm Jose. How do you do this? And he was able to explain everything. So I said, can I see your records? And he showed me the records. And I was able to see that the PLC says something like, to say a number, 160.03. So I can tell that the display is accurate to the 10th of degree. But when I was looking at the records, this guy was only placing 160, 160, 160, 160. And when I saw the records, I said, oh my goodness, everything is 160? Yes, Jose, this equipment is very precise. Yeah, I know that it's very precise because I can see the screen. The problem is that you are not writing down the decimals. And I said, no, Jose, because our instruction, we were trained not to write the decimal. And guess what? I went to the actual procedure and it was written there. Hey, don't type, don't write down those decimals. We're just concerned about the integer portion. And I said, okay, not a problem. And then I said, how do you calibrate the equipment? How do you know that that reading in that screen is accurate? Oh, Jose, it's extremely accurate. Look at the specifications of the PLC of the computer that is controlling that. I believe it was plus or minus 0.1% of the reading. And I will say, oh my goodness, that is actually very accurate. Okay. Now, I said, do you have a calibration of the entire system? Because one thing is that you have the calibration of the PLC. Another thing is that you know what is the variation of the thermocouple wire. And another thing is that you understand what is the typical variation of the RTD sensor. And when you combine after connecting, unless you have tested the entire system, you actually don't know what is the accuracy of your entire system. So they hire a company, Bryan, and guess what? I saw the report and the company says between all the documents under the conditions that you have here, you have a plus or minus 2 degrees variation. And I said, well, now, since you started production, all of that product is adulterated with salmonella. Because if you measure 165
Yeah.
or 160 or 158 or whatever is the number, and you have by that report evidence that your reading could be plus or minus 2 degrees, the number is not anymore 165 or 160 or 158. The number is going to be 158, 156, or whatever, 162. Is 2 degrees less than what you have there.
Right.
And this is exactly the reason why when we are training people in HACCP or preventive controls, we talk about operational limits. Because one of the good things about setting up operational limits is that we can use them in order to compensate the typical variations of the instrumentation that we're using.
Yeah. Yeah. And smart companies, right? If you're pasteurizing and things like this, right, you're never even close to that limit, right? So if your target is 165 degrees, you're actually running at 170, 175 to make sure that if you miss something in this process, that you're not going to be going below that limit, because you cannot go below that limit, period.
Actually, look at this, Brian. Let's say that there is a temperature. The temperature is 150, to say a number.
Mhm.
And you have a process authority in telling you in a report, you cannot go below 150, period. Okay. So now, the first thing, which is exactly what I want to address these issues, is telling people what should be the right sequence that we should go whenever we need to measure something. So we need to achieve 150, and that's what process authority told us. So that's basically the right information that we need to achieve. So then we're going to be purchasing a piece of equipment because we need to measure that.
Mhm.
Whenever we are purchasing the equipment, the first thing that we need to do before purchasing is, hey, send me the specifications of the equipment so
Yeah.
I can read them and I can learn about the accuracy of the equipment, because the accuracy of the equipment is going to depend on its construction. And actually, I have an example here that I just pulled randomly from online. I said, I made a search online, like
Uh-huh.
anybody will do right now to purchase a piece of equipment. I'm trying to focus on a handheld thermometer. And I
Okay.
found one from a reliable company, and it says, this super fast and accurate thermometer can read between 2 or 3 seconds. That's the time that it will take to give you the precise temperature, and the accuracy is plus or minus 0.7 Fahrenheit. It's extremely accurate.
Yeah.
Now, this device cost $99. If I go to another company online, I'm going to find another thermometer, food thermometer, digital infrared for meat and whatever, $759. Okay, that's a cost.
Uh-huh.
And when you read the specification, it says it will take 6 seconds, almost double, and the precision here is 1 Fahrenheit, one Celsius, which
Ooh.
is 2.2
Yeah.
Fahrenheit. So people need to understand that whenever they are purchasing equipment, they first need to look at the specifications, to look at this data. Look
Yep.
at this information, understand what is the construction of the equipment. And one of the biggest problems that we're going to have here is that because on a regular basis, quality control and purchasing are not connected. What is oh, we need a thermometer. Not a problem. I'm going to find you a thermometer. And these guys are going to look for the cheapest one,
Yes.
which is the one that is going to have the biggest variation in accuracy, the poorest accuracy, because it's
Right.
the
Yeah.
cheapest one.
Yeah, you need thermometers that are traceable to a standard, right? Back to NIST, you need to have that reference thermometer, all those type of things to make sure, right? Again, back to what we talked about at the beginning of our conversation, Jose, is you have to be able to defend your data, right? If you can't defend your data, you've got some big problems. One of the rules of thumb I've always used when buying equipment, so let's say like scales and pH meters and things like that I'm looking at for quality purposes, I want them at least 10 times as accurate as what I'm measuring. Why is that, right? Let's say that we have a pH meter and I'm reporting out data at 0.1. I want a pH meter that goes to 0.01. Why is that, right? In particular, we're talking about the meter and also the probe, right? Because to your point, these things work together. You need that accuracy so you can determine rounding, right? So, okay, I've got a 7.16. Okay, well, that's a 7.2. I've got a 7.14. It's a 7.1, right? You need to understand that. And you report to that point. You don't report out all the way because you don't know for that next digit what it really is, right? Because now you're getting down farther and farther. So you need to understand that and be able to purchase equipment accordingly. That'll help you kind of defend what you're doing on these things. Part of this too is understanding what things are in scope and out of scope. Because in lots of old plants, for example, you'll have hidden dial thermometers on silos and all kinds of things. And an auditor may come up and say, all right, I want to see calibration for that, right? This gets back to why it's so important to log and keep track of all of your calibratable equipment. If that's not a tracking device that's used, well, number one, you should remove it, right? Because now it's a cleaning risk. And if you can't remove it, right, you need to make sure that that thing is marked in some way or taken out of service. So that, who knows, right? There may be some person in the plant who is looking at that, thinking that it's a good piece of equipment for measurement, and they're writing down numbers off of that, and you have no idea, right?
Yep.
Really, really important to do that. You need to keep track of that stuff.
You know that I'm looking at Rafael Garcia.
Yeah.
Rafael, you just put a wonderful comment there. And believe it or not, Rafael, this is something I'm teaching in each and every single class that I'm teaching. Hey, guys, you know what? Critical limits, fine. We need to understand what is a critical limit. But after that, we need to understand what kind of equipment we are using in order to determine the accuracy of that equipment. We need to understand the typical variability of the process in order to determine what is going to be our operational limit. And once we identify the operational, every degree, I'm going to talk about temperature, any degree or any increase in pH or decrease in pH or whatever change, any change is going to start affecting the quality of the product. So right on the nail, Rafael. Thank you.
Yep. And yeah, totally agree on that. Helen had a good point here around NIST and tracing. Absolutely true. Gentleman calling in from UAE, Arab Emirates, Dubai. Welcome. So part of this with your measurement devices, and you referenced this earlier, and I want to circle back around to this, Jose, is a lot of the specifications you were reading said this is accurate when you're reading and you let it go for this period of time, right? So after 3 seconds, you can take the reading type thing. Training on how to do the measurements, super important. I worked in a company that had a bakery. And we were looking at our process to figure out what variability we had at different steps in the process. And one of those is we were taking the temperature of the dough after mixing. And I would look at the production records, and it was every reading was 75, 75, 75, 75 degrees F, right? Every single one. And I'm like, really? That's amazing. I'm going to go watch and see how they do this.
That's impossible.
Number one, they had those cheap little pen digital things where you poke them in things, right? They cost like $1 or $2 each. No way to calibrate them. Who knows what they're reading? And I was watching the operator do this. And what he would do is he would mix the dough, stick his thermometer into the dough, and then watch it. And, so he would kind of sit back and watch it. And the temperature would go up and up and up. And as soon as it got to 75, he pulled it and wrote down 75. I'm like, why'd you do that? He said, the dough temperature needs to be 75. Once it's 75, I don't care. I'm like, I said, let's try something. Let's leave the thermometer in a little longer and see what the temperature goes to before it stops. He's like, okay. And he looked at me like I was crazy. And so we put the thermometer in the next batch, and it was like 82 when it finally settled. And the plant manager about hit the floor when I showed him that data, because this hidden variable, this data was bad. And we were looking at quality deviations in the bread, and that was why the dough was too hot.
Yep.
And we didn't even know.
Yep. Yep, exactly right.
Yeah.
So going back to that, I'm going to say structure sequence for the instruments. So first, before you are going to be purchasing the equipment, you need to read
Mhm.
the manual to understand what is the accuracy. Because I mean, you may buy one $99 thermometer, and I already showed you the example, and one $7.59 thermometer. They are not going to be the same. Okay.
Nope.
So accuracy is defined, accuracy of instrumentation is determined by the difference of a measure value compared to the true value. And again, the true value might not be known, because, I mean, there is no instrument that is going to be 100% precise,
Correct.
period. Okay. So then once we say, okay, that accuracy is good for me. So the 10 times that you mentioned, Brian, whatever it is the methodology, we are going to agree that whatever is the accuracy of that instrument is fine with us. It's okay with our system.
Right.
So after that, we're going to be purchasing the equipment and calibrating the equipment, because calibration is the documented comparison of the measurement device to to be calibrated against the traceable reference device.
Yep. To
That's
Helen's point.
calibration
Yep.
by default.
Yep.
And once you know that your equipment is calibrated, is when you in-house are going to start checking for the precision and repeatability. So we're
Mhm.
talking now about instrumentation. Okay. Precision is the ability that when you're measuring, when you're taking several measures of the same thing, all of those measures should be grouped and should be grouped very close to whatever is the accurate value.
Right.
Okay. When you have that, you have precision. And then the repeatability is when you are performing exactly the same test over and over and over and over, and you get about the same results. So
Yeah.
it's repeatable. So one of the things for the repeatability, which is I have never seen this in any of my years of auditing. I'm saying, okay, what do you use for checking the temperature there? Oh, we use a handheld thermometer. Really? And how do you know when to change the batteries? How do you know when the batteries are good or not? Because your equipment is not going to work exactly with the same accuracy if the batteries are 100%, 50%, 25%, 12%, 10%. Who's checking this?
Good point. Mm. Yep. So back to our point earlier, right? So you need to understand, right? You don't have to buy the $99 thermometer for everything, right? But you need to
No.
understand in your plant what are those critical functions that require precision, accuracy, and repeatability, right? Food safety, food quality operations, right? If you have a wall thermometer in the warehouse and you're just kind of generally keeping track of the temperature for information, okay, probably, most thermometers are fine. You don't need to spend a whole lot of money. But the more important the process, the more important what we're talking about in getting that equipment and understanding and then fighting with the people who control the money so they understand why you need to buy the $99 thermometer instead of the dollar thermometer.
Yeah. Yep. Exactly right.
Yeah. So here's an interesting point too that people, and this is going to be becoming more and more prevalent in the food industry. This is already in medical device and other areas, and FDA watches this really closely, and that is software control. Right? So you have your metal detector, right? And in our earlier example, the company comes in and they validate it and they set it up and they make sure it works for your product and all these type of things. And you then have the process of verifying. Those controls on that metal detector need to be locked out. Because let's say, for example, right? Let's say now that that metal detector keeps knocking product off, right? And you're not being told about it in quality. And that operator is getting really, really frustrated. And he just goes in and changes some settings so it works and goes, okay. If that happens, right, your entire system is at risk. Your pasteurizer controls. your RTDs, all of this type of equipment. How is that software controlled and locked down so that once those parameters are set, people can't go in and change them?
Yep. Yeah. And another one, another thing, Brian, that is somehow related with the same approach of calibration and accuracy checks. Look at this one. How do you calibrate a pH meter? Oh, you are going to be using a reference buffer. Well, guys, let me tell you one thing, and this is something that I discovered many times during my audit. Those buffers, they do have expiration dates.
Yes.
And if the buffer is expired, you are not calibrating anymore because it's not going to work.
Right.
And the other, which is the second one, the test, rapid test or test kit that you use, they do have expiration dates. You cannot use something that is expired because it's not calibrated. You cannot rely on the accuracy of that test.
Yes. And here's a little interesting thing on pH meters too, is this is the importance back to training again. So a lot of modern pH meters, when you hit read, it has an auto read function and it will give you a reading after 30 seconds or whatever, right? It beeps and it gives you a reading and people write it down. That may not be long enough. I worked at a company where we were producing liquid sucrose, a really viscous, thick product. And it took that pH meter a good 3 minutes to get to a stable, repeatable reading. And so you would have impatient operators who want the pH of their product, read, and it goes beep and they write that number down. And I'd be like, hold on a minute here. Let's let this sit for a while. And sure enough, that pH would creep up and creep up and creep up. And then you would get the accurate number, right? Training on these things. Super important. And if you have a really viscous product with like that, where it doesn't have a lot of water in there for the meter to read, that's going to be really hard on your probe, right? You need to understand that, and you need to have a process in place for recharging your probe and all those type of things. Is it a sealed one? All of these type of purchases, right? Calibration is a complex subject.
It is. It is. And I believe that as a general approach, I mean, I've seen people doing very good jobs. But in general, Brian, I think that people don't fully understand this topic well enough.
Right. So you're only as good as your data. Absolutely only as good as your data. And you 100%. Have to defend that data. So when FDA comes in and you have a recall situation and they're challenging that data, how do you know it's right? You have to be able to have this conversation we're having right now. This is all back again, Jose. It all comes back to the basics. Plan, do, check, act. Here's my plan for calibration. Here's how I do it. Here's how I check my results. And if it's out of compliance, here's what I do to get things back in. And here's the investigation I perform. That loop, everything we do.
Root cause analysis.
It all comes back to that. Let's see. We're running out of time again, right? So, right, we've talked about getting the right equipment, getting the right training, understanding in your facilities the importance of getting the right equipment for the right point in that process. More important the process, the better the equipment needs to be. PM, right? We haven't even talked about PM. How are you then rolling this equipment into your preventive maintenance programs? So a lot of the bigger equipment in the plants, so scales and load cells and RTDs and these other things we're talking about, right? You have an outside company that comes in once a year and calibrates all this equipment in one big shot, right? And then they give a report, which generally sits in the maintenance manager's office and nobody looks at it, right? You need to look at that report and find out what was going on with that report. What tolerances did they find? What corrections did they have to make? Does that impact food safety, food quality, or operational parameters? You need to understand.
And you know what?
Yeah, go ahead.
Let me interrupt you for a second, Brian, because you're touching something critical now. Calibration is a verification activity by default, and it's a verification activity of an instrument that is being used during the measurement of a conditions that will somehow take care of a hazard. Okay? So because of that, any document that is related to the verification activities of a preventive control or a CCP, I mean, you call it as you wish.
Yeah.
those documents must be signed or initial and dated, and that is mandatory since the preventive control within 7 working days
Good
of the
point.
performance of that activity. So if you receive a certificate of calibration from your supplier of services for calibration, I'm expecting that you are going to read that document, make sure that the information there is the right one, and then sign or initial and date that that thing, I mean, the reading was done, and you agree with the information that is there. Same thing for pest control when people are receiving pest control records. Same thing when you are receiving lab results from a lab.
Yeah, good point. Well, and this is within the regs around FSMA and PCQI. The one thing that people forget then a lot of times is the qualified individual, right?
Yeah.
Who are the people performing these measurements within your food safety plan, your prerequisites and your preventive controls, and are they qualified to do that test?
Yeah. And touching that topic, Brian, the performance, the execution of principle number 4 must be a qualified individual. But the verification and the validation can only be performed by a preventive control qualified individual or someone that is overseen by the PCQI.
Correct. Yep, absolutely. So bringing it back up to the 30,000 foot level, hopefully we've been able to kind of convey to people and get you kind of thinking around calibration, right? Calibration is the bedrock of how do you know? How do you know that it's right? And if you can't answer that question, you've got a big problem because you have a hole in your system and you need to be able to explain and understand it. And calibration, again, is kind of one of those things that we just take for granted. It's like, it's just equipment and things like this. No, calibration is critical. And to our earlier example, with 1.6 million cans recalled because of a bad reading, this can severely damage your company really, really quickly if you're not paying attention.
Yeah. 100% with you there.
Yeah. So hopefully we've given everybody a lot to think about here on this Friday morning relative to calibration. So go back and look at this and look at what the regs say and look at what the quality standards are saying and understand those, right? Because like most things that we do in this space, everything is tied together, right? Training and calibration and all of these type of things. It's just not one category within a standard. It impacts everything, right? This is a system. They call them quality systems for a reason. They're not standalone. And calibration is right there at the bedrock of making sure that everything works right.
Yep. Well, actually, if we use the same language that is in the ISO 9000 for the definition of a system, is a group of interacting or interrelated elements. Well, calibration accuracy check is one of the elements of your system.
Absolutely. Absolutely. It's all this. So once again, Jose, fantastic conversation. Thank you, everybody. Rafael, amazing comments as usual. Thank you, our friend. Helen, great to see you here as well. And NIST, super important. But everybody, thanks again. We will be back here on Friday next week, of course. And as always, I'll say this again, like I say every week, is this is interactive and meant to be a conversation, right? So we really, really love the comments, and this makes it so much fun for us. And we take requests, right? So what topics would you like to hear about? What would you like to learn more about that we can talk with and help get a better understanding for everyone, right? Because food safety is not a point of competition. So my email is here. Jose's email is here. Reach out to either of us and let us know what you would like to talk about. And we'll see you back here next week. Oh, and don't forget, Michelle Wood, my assistant, puts together an event every week. So you can sign up for the event now, and then that'll get on your calendar. You'll get more reminders. So if you're available, it's a great way to get that information and make sure that you're here to participate, because we love having you. And with that, everybody, enjoy the weekend. Have a great one. And we'll see everybody back here next week.
Bye-bye, everybody. Have a nice one. Hi, Brian.